Okay, so for solving linear systems by elimination, day one, the old textbook actually sort of divided elimination into 2 days. So you'll see, I think it might be after the second elimination day, it says the homework for this note, it says handout at the bottom. That's what they're talking about, this handout. Okay, so the questions are there, and as well as the answers. Because it's from the other book, you can't check your answer. And please note as well, it doesn't say to do every single question, okay? Because they're all really similar. If you want to do more practice, so if it says for ACE, then do B, D, okay? If you need more practice. But elimination is pretty straightforward. And usually students, like when we do the word problems and you get to pick, students prefer elimination over substitution, okay? So what we're going to do is we are going to get rid of or eliminate a variable, which means we want it to get to 0. So one of the variables has to be positive and one of the variables has to be negative. So these questions and the questions from the old textbook, you don't have to multiply or make equivalent equations or anything like that. It should just work out, okay? When we do elimination day 2 after the break, then you might have to manipulate the equations first a little bit, but still, like I said, people usually like elimination better, okay? Pardon? You have to do both, but elimination usually is, when the numbers are weird, is usually better, like for a word problem. Okay, so first of all, you have to make sure your equations look like x plus y equals a number, but usually they are like that. We're going to do the same thing, number them 1 and 2. And then, again, you need to choose which variable are you going to eliminate. And then this is what we're going to have to do for day 2. Find an equivalent system so that they are opposites. So what we want to do is the eliminated variable means it's going to add to 0. So how do we add to 0? You have to have an opposite. And what does it mean by opposite? Opposite sign. Like 2x and negative 2x. When you add those together, you get 0. Okay? Even when you're trying to find the equivalent system, so you don't even have to worry about, is it the lowest common equivalent system? None of that matters. You can pick whatever you want as long as it's going to make the equivalent system. You multiply every variable, every term, and one of them is going to be positive and one of them is going to be negative. It could be the x, it could be the y, it doesn't matter, you pick. So we're going to add the equivalent system to eliminate a variable. And again, we want to make it 0. So, and then the steps are the same as substitution. Then you do the algebra to solve for the variable. Then you plug it into the other equation and you check your answer. Okay? So this whole unit is really finding the point of intersection, an x value and a y value using different methods. And then doing word problems. So similar to the substitution note, what the first example is filled in for you, and then we're going to do 2 other ones. Okay? All right, so you rearrange the equations so that they look like x plus y equals a number. Both of our equations do, that's fine. Number them 1 and 2. Again, the convention we use is a 1 with a circle around it and a 2 with a circle around it. So choose the variable to eliminate. So here, today, so far, we're going to choose x because it's already negative and positive. It's going to cancel out. And we're going to add the equations together. So you can think of it like you're in, learning stacked addition, you're in grade 3 or whatever. So people will write it just like this. They put a line, they put a plus sign, and then you're adding the columns. Okay? When you first do this, you can put in the 0. A lot of people will not, but you can, especially when you're first doing it if it doesn't make sense. So negative 3 plus 3x is 0. 4y plus y is 5y. 7 plus negative 2 is 5. Again, it doesn't show that divide step if you want to add that in there. And now it's, yes. It would have to be, they would have to be, if this was plus y, this would have to be minus 4y. So if none of them work out like this, I'm going to show you what to do in day 2. Okay? So we're going to practice these ones first, where you don't have to manipulate the equations, and then we'll do the other ones. Okay? Okay, so now we have a y value. So this is the same as substitution. You sub it into one of the equations. Because technically we haven't, all we did was add these two together. We didn't substitute one into the other or anything like that. You can pick whatever one you want. So wherever you see a y, you put the number 1. You get an x value. And there's your point of intersection. And then make sure you check. Okay? So again, you're going to check in both. Check left side and right side. Again, one of the sides, usually the left side, will be a little bit of algebra work, and the right side will just be a number. Okay? Okay, so Claire asked a good question. What happens if they're not the same? But today, when we do this for day 1, then they should be the same. Okay, so practice doing elimination first, and then we'll get into the harder questions. So this one, they're already set up nicely. They're already x plus y equals c. We're going to label them 1, 2. Which variable should I eliminate? Yes, y. We are trying to eliminate it and make it equal to 0. So check. If I do x plus 3x, what do you get? Right, that's not 0, right? If I do plus y minus y, what do you get? 0. Okay? So even right in the 0 for now. And then pick, even when we do word problems, you'll see usually one of the equations is a little bit simpler than the other one, but it doesn't really matter. It doesn't say to check, but I'm going to slide it in there. So now we have to rearrange these ones because they're not in the same form. The rearrange step, again, if you are really good at this, maybe you don't even need it, but it just helps to visualize which variable am I going to eliminate, okay? You do have some choice here. The first one's already in y equals mx plus b. If you want to make the second one in y equals mx plus b, you can. Or if you want all the questions to look similar, let's just make it look like x plus y equals a number. So we're going to bring the 2x over. Actually, I'll write it up. Okay. Which one am I going to eliminate this time? X. Yes? And really, today, for this one, these simple ones, you actually could just do the adding, and one of them should become 0. However, like I said, these elimination can get a little bit trickier where you have to make an equivalency, so it's good to get in the idea of trying to look for the ones that are opposite signs. So 2 minus 2x is 0. Y plus y is 2y. Negative 5 plus negative 1 is negative 6. So now you have a choice as well. So maybe you don't trust yourself and you want to go back to the original. Okay, there's no fractions here, so you can do that. If you don't trust your rearranging. I could have chose to sub the y equals negative 3 into 2. I should get the same answer. So there is a little bit of variety. Yes, Philip. When you do elimination, it doesn't matter. So when you do substitution, whichever one you rearrange, let's say you rearrange number 1, then you sub it into number 2. Yeah, because you're eliminating it really from both, right? Most people pick the first one because it's the first, but it doesn't matter. Okay? Okay, so now your break's at 10:25. So then at 10:30, I'll start elimination day 2. So right now, you have, half an hour. The substitution homework is in your textbook. The elimination day 1 is you look for this sheet. I believe it's after elimination day 2, okay? And in that package, there are answers for that, okay? There's also, today the booklet I gave you was practice quizzes. So you can do the first practice quiz, the graphing to find the point of intersection and substitution. The elimination one, you need the day 2 stuff for, okay? The solutions for the practice quiz are on D2L. These homework questions are on the notes, but they're also on D2L as well, okay?